Okay, recording has started. We are on lesson 8, derivatives of logarithmic functions. In order to successfully do this, you need to remember both the log rules, again, refer to formula sheet, as well as the derivative rules, which we're going to introduce today. Okay, the proof that this is true. Here's the rule. It's on your formula sheet. I will prove to you that this rule is true. Let y, I'm going to do substitution essentially, okay? Equal log a x. If this is true, so we always start proofs with if-then statements. If we're assuming this is true, then a to the y equals x. Change of base, right? The inverse. Okay, now if I take d by dx of this, what would I get? What's the rule for exponentials? Ay ln a, thank you, then y prime, right. What is the derivative on the right? 1. Okay. So y prime is 1 over a to the y ln a. What does a to the y represent? Ah. Oops. In my head here, x ln of a, because we said this substitution. X represents a to the y, so I can substitute it back. Are we convinced? Are we happy with this? Okay, so this is where this rule comes from. Similar to how we did our trig rules. Sometimes looking at the inverse and differentiating implicitly is easier than doing it directly. Okay, the other rule is essentially the same, but if my base is ln e, right, ln e is 1, so I'm just left with the x on the bottom. Okay, this is the same as saying d by dx of log base e x, which by this rule states that it will be x log e base e. Log e base e is just 1. Simplifies to this. Okay? I was going to do a proof, but I just did it. Haha. I was supposed to write that down here. Here's your proof. Okay, so I'm just following the rule I proved up here, but we know that log base e we call ln, and ln e, right, the log of a base of the same thing is going to be 1. So it ends up simplifying to just 1 over x. Are we okay? Yeah. Okay. Well, I was going to give you a harder one to differentiate. That's okay. Let's do example 1. Okay, rules I need to consider when I look at this. Chain rule. Log rule and power rule as well. Yeah. Right, because inside I have an exponent. Okay, so if I let, I don't know, let's pick another letter, a equal x cubed plus 1, then a prime is 3x squared by the power rule. Yeah.
Don't we already have a rule that says ln of x would just become, the derivative of ln of x would just become 1 over x?
Mm-hmm.
So shouldn't that just equal to 1 over x cubed plus 1?
I still have to apply the chain rule.
So we have to apply the chain rule before you different. So that, okay.
So this is like saying ln of a.
All right.
So y prime is 1 over a, but chain rule times a prime. Right? So when I substitute back, this is a prime, 3x squared, over a, x cubed plus 1. When we do examples, especially the first few, I do everything very explicitly. And then once you get the hang of it, we can start skipping steps. Okay, so following rules, that's all we're doing. Differentiate x, ln x, and ln of x squared, 2x minus 5. What's the rule I need to consider in the first one? Product and ln. And then the second one?
Product, ln, and
Not product.
No, I mean chain ln.
Chain ln. Okay. So derivative of the first thing is 1 ln x plus x times 1 over x. So y prime is beautiful. Ln x plus 1. Okay, going over to this one here. So chain rule, right? Call this A. Now I'm going to skip the step and do it in our heads. Y prime will be 1 over the inside, x squared plus 2x minus 5, times the derivative of the inside. What's the derivative of the inside? 2x plus 2. Now I can do this in my head. You were doing rocket science in your head. Come on, guys, this is so cool. Yippee. You're like only 10 years away from working at NASA. It's better than 30. All right, any questions, comments, concerns? Yes. Okay, let me back up. I called this A, and therefore A prime is 2x plus 2. I'm taking the derivative of the inside. Yeah, because y prime, if I wrote it like this, pen work, y equals ln a, y prime is 1 over a times a prime by the chain rule. So I just did all that bit in my head because Joe complained that I didn't do it in my head on the last page. But it's the same example, right? I have a chain rule, so it's 1 over the inside of the ln times the derivative of the inside. Whenever we multiply fractions, tops go together, bottoms go together. Are we okay? Can I move on? Yeah. Okay, let's go on. In general, we can combine the derivative of ln x with the chain rule, and the general rule will be this. If you have a derivative of a ln with a chain rule, so a function inside, it will always be derivative of the inside over whatever's in the inside as is. Okay, shorthand. I don't think that is on your formula sheet, but you can remember that. Okay, and if you don't remember that, as long as you understand how chain rule works, you're going to get there anyway. So Either remember chain rule or remember an extra rule. It's up to you. All right. Let's do this one. I want you to do it in one step. Oh, negative 10. Way to go. The inside unchanged goes in the bottom. The derivative of the inside goes on the top. Trig identity, sine over cos gives me tan, so this is negative tan x. Identities are also on your formula sheet, at least the one that we're going to use in this class.
All right.
But just FYI, this identity is from grade 9. You should know that one. You did do trig in grade 9. Who was your grade 9 teacher? You definitely did trig in grade 9.
Miss Gill. We had Miss Gill.
Okay, let's stop talking about teachers while I'm recording the video. We'll continue.
Right.
Let's keep going. Okay, the next example. Now I have chain rule again, but now the ln is on the inside of the chain rather than the outside of the chain.
Right.
Oh boy, what do I do?
So we converted it into a fraction exponent, right?
Sure, let's convert it to a fraction exponent. F equals ln x 1/2. F prime is chain rule.
So it would be ln x. No, wait. Okay. 1/2 ln x. Yeah.
Who's saying it? I'm hearing somebody from over here. You're not done. Keep talking.
Times. Yeah.
Okay, now make it pretty.
1 over 2x. No, wait. 1 over 2x root ln x.
Everything's in the denominator.
1 over 2x root ln x.
Okay, there we go. That's prettier.
Yes, sir.
Ma'am, thank you very much.
My bad.
Did you know that in the military you say yes, sir, regardless?
Yeah.
It's very cool. Pardon? I think it's just, yeah. It's anyone who outranks you is a yes, sir. Pardon? You can call me sir, I don't care. Just don't call me bruh, and we're okay. All right, next one. We're off task. Reel it in. Do the next one. In one line. I want it to be pretty.
You want it to be pretty in one line?
I want it to be pretty in one line.
4 ln x cubed divided
Done.
by x.
Beautiful. You're doing derivatives in your head. Yay. Who would ever think that you're such capable students? Okay, I want to give you a difficult one that's not on your page. Grab a spot or a piece of paper or your notebook. Try this. These ones are clearly too easy. Yep. Okay, go. Go ahead. Go ahead. Oh, great question. Do we start on the inside or the outside? Which rules do we need? It's a triple, yes, it's a triple sub. Triple sub. We have inside, middle, outside. This is a triple chain. We have a log, a trig, and a power. If anyone is going to do the product rule, I will smack you right now. There is no product rule. All of these are functions within a function. They are not timesing each other. And I want it to be pretty.
What's that in the bracket?
Not opposite, not inverse, it's derivative. Okay, there's your triple sub. I'm even helping you. Is it?
Is it 8x cubed containing 2x4?
Yes.
8x cubed cos containing 2
It's COT.
Yes, COT.
It's COT, cotangent.
cotangent. Yes. That's fine. It's just not pretty. You always, especially when things get this ugly, you want to try and define the cute, right? When you go through puberty and your hormones are terrible and you're like a living nightmare to live with, your parents are like, okay, this kid is horrible and ugly and awkward, but like I still kind of love them, right? That's what we do with math. You have to go through, we're not off track again. This is what we do in math. You go through growing pains. You start off really cute with 1 + 1 is 2, right? And then you go through the awkward phase of pre-cal and calculus, and this is like disgusting. And then we make it cute. We put makeup on, right? We look for the cute and the simple because cute and simple is what we need. Little bit of makeup, a nice cute little dress, and then off we go and we're ready for prom, okay? We are always trying to make it look better. Very rarely will you receive a question, especially in my class, where it is just disgusting. And the midterm question is an exception. Yes, I know. The midterm question was an exception. But most of the time, I'm pretty good at making sure your questions work out nicely. And if it doesn't, I will tell you, you're looking at an ugly answer. And that's okay. Sometimes we have to wear braces for 3 years, and that's just how it goes. Okay? Yeah, I wore braces for 3 years. It's just how it is. Okay, are we comfortable? Ish? We're like understanding the game here, okay? So let's go back now. Here's a simpler one. Differentiate 5 all by yourselves. Oh, language.
What did I do? What is it?
Good catch.
No, it's not long.
I would question it.
Yeah, but like, does it just simplify into long?
No, it's
How did you get negative?
Yeah, I got, and then. Oh, the last one? Oh, okay.
The log rule says it is the reciprocal of the inside times the ln of the base. When you see a log with no base, the assumption is 10 because that is just the standard notation. So it's ln 10. This one. Who's dropping emojis? I'm not going to be the emoji police. Let's move on. Okay. Let us look at, okay, what other ones? Take a look at what you've got there. You have example 6. Oh yeah, let's do example 6. There's 2 ways to do it. Using chain rule or using law of logs. Oh my gosh. It's Friday. I can feel it. I know not. Just go with it. If I did this with chain rule, okay, if I did this with chain rule, I'm going to substitute y equals ln a, and y prime is 1 over a prime. A is x over root x plus 1. Call this f, call this g. I need to use the quotient rule, right? A prime. Quotient rule. Which derivative do I start with? X, 1.
X becomes 1.
So multiplied by the bottom unchanged, plus, or no, minus, thank you, x. What's the derivative of the bottom?
1/2 x. X plus 1. 1 over 2x.
All over.
Wait. Okay.
Did we follow that? Right? F is x, so f prime is 1. G is root x plus 1, so its derivative is 1 over root x plus 1. And then the bottom is squared. Okay, stacked fraction, don't like them. Do I need to worry about that right now? Should we chuck it in, or should we try to simplify first? Yeah, I can remove the root here because I have the square root squared. So that'll be positive. Okay. Let's not simplify it just yet. Let's just put it in to the y prime equation. So a prime, so this stuff here, root x plus 1 minus x over 2 root x plus 1 all over x plus 1 times, so this is a prime times a, but a is in the denominator, so it's the reciprocal, right? This is root x plus 1 all over x. Okay, so what I just did is a prime times 1 over a. Did we follow that? Okay. Okay, if I do this, I see that the numerator does get simplified, but I still have a 2 in the bottom. So let's multiply by 2 over 2. Right? Because I don't like that this is stuck there. So I'm going to multiply everything by 2 over 2, and then we're going to distribute. Y prime is x plus 1 times x plus 1, both in roots, is just x plus 1. Minus x, because the denominator and the numerator cancel out. all over 2x squared plus x. And I can simplify this further.
Plus 2x, not just x.
Thank you. 1 over. Nope. Oh, here. Ah, okay. So I did simplify this incorrectly. Let me just reduce. So this would be, let's see, 2x plus 2 minus x. That becomes x plus 2. Is my denominator okay?
Well,
I
we just
could factor the
that.
2x, x plus 1. See, it's cute. It was ugly, but it's cute. That's such a cute little fraction. Come on, of all the things we've seen, this is pretty good. Okay, so this method goes in chain rule, essentially brute force, just do what you see until you get down to the final answer. I'm going to show you another method. What if we use the laws of logarithms? How could I rewrite this? Whoopsie, that was not supposed to be an x there. How can I rewrite this using laws of logs? No, he's right. Keep going. Yeah, I could write this as ln x minus ln root x plus 1. And then I can use the difference rule, right? If I have multiple pieces that are plus and minusing, I can just do the little pieces on their own and then stick them together, right? Y prime is
Oh, 1 over x
minus.
minus 1 over root x plus 1 plus the derivative of root x plus 1.
Which is?
Which is 1 over 2x plus 1, root x plus 1.
Okay.
Big problems.
Make it cute.
Right.
We're almost there. Come on. You can do it. Yeah.
So we need, okay, we can't really do anything else. Yeah.
But it's cute.
Yeah.
However, it needs to be the same as what we had before. Is it the same as what we had before? No, kind of. If I common denominator this, right, I'm just going to double check. If I common denominator this, I'm going to get 2x plus 2 minus x all over 2x bracket. Nope. Try again.
2x bracket x plus 1. That would have worked.
I know, but I want to write exactly what I have.
Okay.
To show, to prove that these are the same. Boom, boom. Which one's easier?
This one. Which two?
Chain rule. This is x plus 1 to the power of 1/2, so that 1/2 comes down. Okay? So sometimes we need to work smarter, not harder. Could we do the chain rule way? Absolutely. It'll take us twice the time. So ln rules not only help us simplify things, but typically will usually make doing the derivative easier. And tomorrow's lesson is like a deep dive into how to use this method, okay? Do we want to do this one? What does the absolute value mean? Okay, let me ask it in a different way. Is ln of absolute value x differentiable? Not at the turning point, right? So that means this is a what kind of function? Yes. Okay. This is a piecewise function. This is saying I have ln of x if x is positive. I guess it can't really be 0, so let me just do that part. And then it's ln of negative x if x is negative. When we see absolute values, we need to be very careful because absolute value functions are not defined everywhere. Sorry, they are defined everywhere. They're not differentiable everywhere. So where there is a breaking point, we need to make that a piecewise function, right? And then piecewise functions are very simple because then you just have the little pieces that we have to worry about. So f prime then is also going to be a piecewise function. If x is a positive value, what's the derivative? 1 over x. If x is a negative value, no.
No negative, not negative. Oh, right, it's chain rule.
It's a chain rule.
Negative, okay, it's gonna be 1 over.
It's going to be 1 over negative x times negative 1 because I have a negative inside the ln, which makes it a chain rule. The negatives cancel out. So I have 1 over x again. Does that make sense?
Yep. It can be differentiated at 0.
Cannot be differentiated at 0.
So it's like, it does not exist at 0. What? That's a chain rule.
It's a chain rule, right? The derivative of ln is 1 over the inside, so I get 1 over negative x. Times the derivative of the inside, that's a power rule. I have to multiply it by negative 1.
Right.
Okay, we are at the homework page. Woohoo! We're done. Stop recording.